Simplifying radical expressions. Our objectives. At the end of this presentation, you should be able to derive the laws of radicals and simplify radical expressions using the laws of radicals. Let's start. What are the laws used to express radicals in the simplest form? Number 1. The nth root of xy is equal to the nth root of x times the nth root of y. This means the nth root of a product is the product of the nth roots. Number 2. The nth root of x over y is equal to the nth root of x over the nth root of y. This means the nth root of a quotient is the quotient of the nth roots. Similarly, we can also use the following laws to simplify the radicals. The m root of the nth root of x is equal to the m times nth root of x. So for number 2 example, if a radical is inside of a radical, then copy the base and multiply their index. Number 4, if x is real number and n is odd, then the nth root of x raised to n is equal to x. Number 5, if x is real number and n is even, then the nth root of x raised to n is equal to the absolute value of x. Remember, the strategy to simplify radicals is to express the radicands as the product of two factors such that one of the factor has an exact indicated root or a perfect nth root power. Then, use the laws of radicals. Example. Simplify each radical. Square root of 32. As you observe, 32 is not a perfect square number. Therefore, to solve this kind of given, we will just simply get the factors of 32. Factors means two numbers which when you multiply, the answer is 32. So the factors are 1 multiplied by 32, 2 multiplied by 16, and 4 multiplied by 8. As you observe, as we multiply 1 by 32, the product is 32. 2 multiplied by 16, the product is 32, as well as 4 multiplied by 8, the product is 32. The second step is to find among the factors which will be the perfect square number. So, in this given, the perfect square numbers are 16 and 4. They are said to be perfect square because they have square root. The next step is to get the factor which we have a highest perfect square number. So since 16 is greater than 4, therefore we'll be using 2 and 16. So we can rewrite this as square root of 2 multiplied by 16. After getting the factors, get the square root of 16. So the square root of 16 is actually 4. So you'll be writing 4 outside the radical sign. What left is 2. So you'll just simply copy square root of 2. Now since there will be no factor of 2 which is 1 is a perfect square number, therefore our final answer is 4 square root of 2. Example number 2 is the cube root of 24. Same process will be applied. Get the factor of 24. So the factors of 24 are 1 multiplied by 24, 2 multiplied by 12, 3 multiplied by 8, and 4 multiplied by 6. Now, Since the given is cube root, therefore, we'll be finding out among the factors which are a perfect cube number. So among the factor, the only number which is perfect cube is actually 8. Therefore, we will be using 8. So we can write this as the cube root of 3 multiplied by 8. After that, get the cube root of 8. The cube root of 8 is 2. So you can rewrite this as 2 cube root of 3. Since there will be no factor of 3 wherein 1 is a perfect cube number, therefore your answer is 2 cube root of 3. Square root of 5. So as we can observe, 5 is not divisible to the index, which is 2. So we need to expand this. Get the factors of 5 wherein 1 is a perfect square number. So we can rewrite this as square root of x to the 4th multiplied by x. After that, get the square root of x to the 4th by dividing the exponent to your index. So 4 divided by 2 is 2. So we will be writing it outside your radical sign. So we have x squared, then just simply copy what left inside the radical sign, which is x, square root of x. So the answer is x squared, square root of x. The cube root of the square root of 2x. So we will just simply copy the base, which is 2x, and then multiply the index, 3, and since the index is not visible, that is automatically we have 2 as the index. So we have 3 multiplied by 2. So our answer is the 6th root of 2x. So the next example is the square root of 12 over square root of 3. Now we can rewrite this as the square root of 12 over 3. Remember, you can only combine them if their indexes are the same. Now simplify 12 over 3. Dividing 12 by 3 will give us a quotient of 4. Therefore, we have already square root of 4. Then simplifying square root of 4 will give us an answer of 2. Therefore, our final answer is 2. Next is the cube root of 2a to the 5th, b to the 6th over the cube root of 16c to the 9th. So again, we will be writing this as cube root of 2a to the 5th, b to the 6th over the 16c to the 9th power. So let's first simplify these numbers. So 2 and 16 are divisible both by 2. So get the lowest term, we have the cube root of 1 over 8. Then just simply copy the given variables. So a to the 5th, b to the 6th, c to the 9th. Then we can now simplify. The cube root of 1 is 1, so we don't need to rewrite it. So we have a to the 5th. So we will be dividing the exponent to the index. So how many 3's there are in 5? So there are only 1. So you can write this as a. And then the remainder will left to your radicand. So we have a squared because the remainder is 2. Next, we have 6 divided by 3, we have 2. So we can write this as b squared over, so the cube root of 8 is 2. And c, we have 9 divided by 3, we have 3. So we have c cubed. So the answer now is ab squared, square root of a squared all over 2 c cubed, or we can rewrite this as ab squared square root of a squared over 2c cubed. Expressed in simplest radical form, the fourth root of 4. So as you can observe, there will be no such number, which when you multiply 4 times by itself, the answer is 4. Now we want to express this into the simplest radical form. So the first step that you should do is to express the radical into rational exponent. So remember that the nth root of x raised to m is equal to x raised to m over m. So I can rewrite this as 4 raised to 1/4. After that, since 4 is a perfect square number, we can rewrite this in exponential form. So rewriting 4 in exponential form will give us 2 squared. And then we raise this again by 1/4. After that, we will multiply 2 and 1/4 since a power is raised by another power. So we have 2 times 1 over 4. Remember that a whole number has a denominator of 1. So multiplying 2 by 1 will give us a product of 2. Multiplying 1 by 4 will give us a product of 4. Lowest term of 2 over 4 is 1/2. Therefore, we can write this as 2 raised to 1/2. After simplifying, we can now transform again the given rational exponent into radical. So we can write this as the square root of 2. Again, where index will be 2 since the denominator of the given fraction is 2. And since the numerator is 1, we don't need to write the exponent 1. So the simplest radical form of the fourth root of 4 is square root of 2. Next is the sixth root of 125. Same procedure will be applied. Let's transform first sixth root of 125 into rational exponent. So we can write this as 125 raised by 1 over 6. 125 is not a perfect square number, but 125 is a perfect cube number. Since there will be a number which when you multiply 3 times by itself, the answer is 125, and that is 5. So 125 can be write as 5 cubed. And then we will be raising this as 1 over 6. After raising this, we multiply 3 and 1 over 6 since a power is raised by a power. So we can write this as 3 multiplied by 1 over 6. So again, a whole number has an invisible denominator of 1. Then multiplying numerator by numerator will give us a product of 3. Then denominator by denominator will give us a product of 6. Lowest term is 1/2. So we can write this as 5 raised to 1/2. After simplifying it, write it again into radical. So we can have square root of 5. Since the denominator of the exponent is 2, then our index is also 2. And again, since the numerator is 1, we don't need to write the exponent 1 inside your radical sign. Therefore, the answer is square root of 5. Thank you.